Hi guys, welcome to my channel. Today we are gonna watch a video called Why America's Tiny Ocean Defies Geography. So let's see why.
On a map, the Gulf of Mexico looks simple enough. It's a gentle scoop.
Gulf of Mexico, but now is called Gulf of America, no? I think Trump was changing the name. So basically now they have to change the full video.
A bite taken out of the southeastern edge of North America. It appears as a vast, placid basin cradled between the United States, Mexico, and Cuba. But to mistake this simplicity for a lack of complexity is to fundamentally misunderstand one of the most powerful and dynamic bodies of water on the entire planet. This is not just a gulf, it's an engine. And its story begins with a scale that's almost impossible to grasp. At over 600,000 square miles, the Gulf of Mexico is one of the largest basins in the world. If it were a country, it would be the 21st largest, bigger than Iran. You could fit Texas inside of it twice, with room to spare. This immense size means it functions less like a regional bay and more like a small ocean, governed by its own set of rules.
I didn't imagine the Gulf of Mexico of the Gulf of America to be so big. I was imagining something very, very small.
Its semi-enclosed nature is the first clue to its unique character. It's almost entirely surrounded by land, a colossal bowl of seawater connected to the wider Atlantic world by just two narrow passages, the Yucatan Channel to the south and the Straits of Florida to the east. These two gates are surprisingly restrictive, forcing the water that enters the Gulf to linger, warm, and change. But here's where it gets really interesting. The true power of the Gulf isn't defined by ocean water that flows in, but by the continental water that pours down into it. An astonishing 33 major river systems draining over 60% of the United States find their final destination in the Gulf of Mexico. And one of these rivers reigns supreme, the Mississippi. The Mississippi River is not just a river. It's a continental drainage system of epic proportions. Every second, it pumps an average of 593 cubic feet of fresh water into the Gulf. It's a difficult number to visualize. So think of it this way. It's enough water to fill the entire Superdome in New Orleans in about 3 minutes. Along with this water comes a relentless torrent of sediment, the very soil of the American heartland, carried downstream for thousands of miles. For millennia, this process built land, creating the vast, marshy delta of Louisiana. The land you stand on in New Orleans was, geologically speaking, in Illinois or Ohio just a short time ago. And this constant delivery of fresh water and nutrients fundamentally alters the Gulf's chemistry, creating a unique environment that is part river, part ocean.
Look at this, so beautiful, these colors.
This next part, however, will completely change how you think of the Gulf because that same life-giving sediment, which built a coastline, is now at the center of a crisis where the land is disappearing at an alarming rate. If you could drain this super basin, you wouldn't find a simple sloping bowl. The underwater landscape is just as varied as the land that surrounds it. Off the coast of Florida and the Yucatan Peninsula, the continental shelf extends gently for hundreds of miles, creating vast, shallow water platforms. But elsewhere, the seafloor drops off dramatically into the abyss. The deepest part of the Gulf is a feature known as the Sigsbee Deep, plunging to a depth of over 14,000 feet. You might expect such a place to be a jagged trench.
I don't know feet, how much is this?
A scar from a violent tectonic activity, but it's not. Instead, it's an eerily flat plain, albeit underwater. This abyssal plain is so smooth because it has been paved over by millions of years of sediment, burying its true geologic history miles below mud. That layer of sediment hides a truly incredible secret, a clue to the Gulf's violent birth during the age of dinosaurs. From the mangrove forests of the Yucatan to the white sand beaches of Florida and the vast coastal marshes of Louisiana, the Gulf's edge is a world of constant change. It's a place where land and water are constantly mixing. We have this immense, river-fed cauldron contained by land with only two narrow gates for water to escape. On a purely physical level, it's a geographic marvel that dictates weather, creates ecosystems, and fuels economies. But this is just the stage. To understand why this body of water seems to defy the very rules of geography, we have to look beyond its modern physical form. We need to rewind the clock to a time when the Gulf didn't even exist, to uncover a story of its birth, that is more bizarre and consequential than you can ever believe. We left off staring into the abyss of the Gulf of Mexico, at a seafloor made unnervingly flat by miles of sediment. That sediment, we now know, hides a secret to the Gulf's very creation. The story isn't one of slow, gentle formation, but of a dramatic and fiery birth during the breakup of the supercontinent Pangaea, around 200 million years ago. As North and South America began to tear away from each other, a new, shallow basin formed in the rift. It was a basin in a hot, arid world, and it was periodically connected to the open ocean. And this is the game changer. Seawater would rush into this new basin, but the connection to the ocean would then be cut off, leaving this vast, shallow sea to bake under the relentless Mesozoic sun. As the water evaporated, it left behind a thick crust of salt. This process repeated itself over and over and over for millions of years, like a cosmic pot of water boiling away, leaving its residue. The result was a truly astonishing geologic feature. A bed of salt, in some places miles thick, carpeting the entire floor of the primordial Gulf. Over millions of years that followed, rivers, including the ancient ancestors of the Mississippi, began pouring sediment into the basin, burying that immense salt layer under tens of thousands of feet of muck and rock. And that should have been the end of the story. But this ancient buried salt didn't just stay put. Salt is a peculiar rock. When put under immense pressure, it can flow like incredibly thick honey. It's also less dense than the sedimentary rock piling on top of it. So, over eons, this buried salt began a slow motion rebellion against the weight of the continent pressing down on it. It pushed its way upward, creating massive, mushroom-shaped columns and domes of salt that warped and...
What? Look at this. Wow. I never saw something like that in my life.
buckled the layers of the rock above them. These salt domes are a defining feature of the Gulf's geology, and they would shape the destiny of the region in a way that no one could have predicted. Fast forward to the dawn of human history in the Americas. Long before Europeans arrived, indigenous peoples lived along the Gulf's rich coastline, but it was the arrival of the Spanish in the 16th century that put the Gulf on the world map. They called it the Seño Mexicano, the Mexican Sound, and then eventually the Gulf of Mexico. And for nearly 300 years, they treated it as their own private lake. It was the liquid highway connecting the silver mines of New Spain to the treasure fleets bound for Europe. This made it a theater of conflict, a hunting ground for pirates and privateers from England, France, and the Netherlands, all vying for a piece of the incredible wealth flowing across its surface. For centuries, the Gulf was a battleground for gold and empires. Nations rose and fell based on their ability to control its key ports, from Veracruz to Havana to New Orleans. But the true treasure wasn't the silver Spanish galleons carried across its surface. It was a black, viscous substance trapped deep beneath the waves, a substance directly linked to that ancient layer of salt. In the 20th century, geologists realized that as the salt domes pushed upwards, they bent the surrounding rock layers, creating perfect traps for oil and natural gas. The very geologic weirdness that began with the evaporating sea 200 million years ago had created one of the richest petroleum basins on Earth. So, the Gulf's history is a dramatic tale, beginning as a geologic accident and becoming the strategic heart of empires, all built on a foundation of salt. Its identity is layered, from an ancient salt flat to the Spanish lake to a modern energy powerhouse. But its history is still being written, not in the annals of explorers, but in the atmosphere above. The same physical features, the bathtub shape, the immense freshwater input, and the deep, warm water that made it a cradle for oil also turned it into a cradle for something far more immediate and terrifying: the world's most powerful storms. Understanding that transformation is the final key to why this body of water truly defies geography.
I see. Wow. Sorry, I don't know really what to say.
How does this mostly self-contained oceanic basin defy the rules of geography? The answer is that the Gulf is not a passive container of water. It is a colossal engine, one that relentlessly absorbs, stores, and exports energy on a scale that alters the destiny of entire continents. You see, the process begins with heat. Due to its southern latitude and semi-enclosed shape, The Gulf of Mexico is a world-class heat trap. Sunlight beats down on the water, and because that water has nowhere to go quickly, it just sits and warm, like a vast blacktop parking lot on a hot summer day. By late summer, surface temperatures regularly soar into the high 80s Fahrenheit. But the real secret to its power is a feature called the loop current. This is a deep, fast-moving river of warm water that flows up from the Caribbean, pushes deep into the Gulf, and then loops back to exit through the Straits of Florida. This current is a massive injection of thermal energy, ensuring the Gulf isn't just warm on the surface, but has a deep reservoir of heat. It transforms the basin from a warm bath into a fully charged, high-capacity battery. This colossal reservoir of heat provides the high-octane fuel for the atmosphere's most violent creation, hurricanes. Hurricanes are fundamentally heat engines, and the Gulf of Mexico in late summer is the perfect fueling station. A fledgling tropical storm drifting in from the Atlantic can suddenly encounter this deep, warm water.
Whoa, I guess this is the part I don't really like.
And explode in intensity. Sometimes overnight, the storm draws heat and moisture from the sea, converting that thermal energy into the ferocious winds and torrential rain of a major hurricane. This is the Gulf's most famous and terrifying defiance of geography, its ability to transform from a placid basin into a nursery for storms that can devastate areas 1,000 miles inland. The Gulf's power to create chaos is infamous, but what happens to all that energy that doesn't get vented into a hurricane? The answer is even more astounding. It flows out that narrow Florida Strait and embarks on a journey that will change the climate of an entire continent a whole ocean away. As the superheated water from the loop current exits the Gulf, it becomes the primary source of one of the most important ocean currents on Earth, the Gulf Stream. The Gulf Stream is a river of warm water, thousands of times more powerful than the Mississippi, flowing within the Atlantic.
Oh my god, with this Gulf. I thought, yeah, just a Gulf and that's it. I didn't think this Gulf have so much influence to the rest of the planet.
Atlantic Ocean. It travels northeast, carrying the immense thermal energy it gathered in the tropics and the Gulf all the way across the ocean. As it moves past Western Europe, this warm water releases its heat into the atmosphere, acting like a giant space heater for the continent. This is the final, stunning piece to this puzzle. The reason London has drizzly, mild winters, while cities in Canada at the very same latitude are frozen solid is, in large part, due to the Gulf Stream. The comfortable climate of Ireland, the United Kingdom, and much of Western Europe is a direct consequence of the heat absorbed and exported by the Gulf of Mexico. A body of water nestled against North America is fundamentally responsible for the habitability and history of nations 3,000 miles away. And without that transfer of heat, Europe would likely freeze and become a much more inhospitable place to live. So the Gulf of Mexico defies geography by refusing to keep its influence to itself. Its unique basin, a product of a violent geologic past, makes it an unmatched heat collector. This energy is unleashed in two dramatic ways. Locally, in the fury of hurricanes, and globally through the persistent, life-altering warmth of the Gulf Stream. It's not merely a feature on a map. It's a critical, powerful, and unpredictable gear in the great climate machine of our planet. Of course, if you live in any of the major cities along the Gulf, you already know this. Going swimming in Texas, Florida, or the Yucatan Peninsula is a far different experience than even along the coast in Southern California, showing that the Gulf is truly different.
Wow, I didn't know that the Gulf of Mexico, now called the Gulf of America, really has so much influence to the rest of the world, to the rest, of Europe. So this is mean that if something happened with this Gulf, the rest is also affected. Wow, I'm learning so much with all these videos. Did you know this? I'm really amazed here. My mind just blew. So thank you guys for watching this video. If you would like to see more content, don't forget to subscribe and like and comment. And see you in the next video. Bye bye.